This is a redox reaction given. Redox reaction is a reaction in which oxidation and reduction reaction take place at a time. Well, to identify oxidation and reduction reaction taking place in this given equation, we write down the oxidation number of atoms on both sides of the reaction. Let me take first reaction, that is ferric oxide. The usual oxidation number of oxygen atom is -2. We calculate the oxidation number of Fe atom. There are 2 Fe atoms. I put here 2 Fe plus. There are 3 oxygen atoms. I put here 3 coefficient bracket. The oxidation number of oxygen atom is -2. We put here -2. Well, the total oxidation number of all atoms in a compound is equal to 0. That is why I put here 0. Now we can simplify this setup and find out the oxidation number of Fe atom. Here we have 2 Fe, 3 2 is 6, we get -6 is equal to 0. Now we can transfer 6 on right side. Here we get 2 Fe is equal to +6. Now you can divide +6 by 2, we get 2 3 is 6, we get Fe is equal to +3. Well, the oxidation number of Fe is +3. Here we have +3. In carbon monoxide, the usual oxidation number of oxygen atom is -2, and if oxygen has -2, carbon will obviously have +2 oxidation number, because +2 and -2 is equal to 0. On the other side, Fe is a neutral atom, means it does not have any charge, and the oxidation number of a neutral atom is always 0. That is why Fe is having 0 oxidation number. In carbon dioxide, oxygen obviously has -2 oxidation numbers, and we calculate the oxidation number of carbon atom. There is only one carbon atom in carbon dioxide. I put here carbon, since its oxidation number is unknown. Remember, when we calculate the oxidation number of a particular atom in a compound, we do not consider the coefficient which is used in balancing the reaction. We only use the number of atoms present in a compound to assign the oxidation numbers. Since there is only one carbon atom in carbon dioxide, that is why I mentioned here only one carbon atom, plus there are 2 oxygen atoms. I put 2 coefficients, and well, the oxidation number of oxygen is -2. I put here -2, and this is a compound, and the total oxidation number of a compound is equal to 0. I put here equal to 0. Now we can simplify it. See, 2 2 is 4, we get -4 is equal to 0. Now we can transfer -4 on right side, we get C is equal to +4. Well, the oxidation number of carbon atom in carbon dioxide is +4. Now we can compare the oxidation number of atoms. Well, the oxidation number of Fe is decreasing from +3 to 0, and decrease in oxidation number is considered as a reduction reaction. I put here reduction. It means that Fe is being reduced in the reaction. It means it is gaining electrons. On the other side, the oxidation number of carbon atom is increasing from +2 to +4. An increase in oxidation number is considered as a oxidation. I mentioned here oxidation. It means carbon is being oxidized in this reaction. Oxidized. It means it is losing electrons. Fe is being reduced in this reaction. It is being reduced by carbon atom. Since carbon is reducing Fe, that is why it is acting as a reducing agent. Reducing agent. On the other side, carbon is being oxidized in this reaction, and since it is being oxidized by Fe atom, and Fe is oxidizing carbon, that is why Fe is acting as a oxidizing agent. Oxidizing agent. Well, the simplest way to identify oxidizing agent and reducing agent in a reaction, in a redox reaction, first we find out the atom which is being reduced and which is being oxidized in the reaction. The atom which is reduced in the reaction acts as a oxidizing agent, and the atom which is oxidized in the reaction acts as a reducing agent.